Which relationships have the same constant of proportionality between y and x as in the equation y equals 1/3 x? So the first thing we should do is find the constant of proportionality in the equation so we know what we're looking for to match up in the graphs and tables. So the equation y equals 1/3 x is in the format of y equals kx. The variable y is completely isolated and x is just being multiplied by something. It has a coefficient of k. That coefficient of k is the constant of proportionality. So in this equation, if we look at the coefficient, we have k equals 1/3. So that's the constant of proportionality we're looking at in the graphs and the tables to try and match up to. So let's go through each of the three graphs and then the tables. To find the constant of proportionality in a graph, the graph must be going through the origin, and then we can pick one of the random points on the graph and look at the ratio of y to x. So graph number 1 is not passing through the origin, so it is not proportional. It will not even have a constant of proportionality. Graph number 2 is passing through the origin. So now we can randomly pick one of the ordered pairs on the graph. Let's say this one. So we have 1, 3. That gives an x value of 1 and a y value of 3. So the ratio of y over x is 3/1. So the graph number 2, or the second graph, the constant of proportionality is 3, not 3/1, so it's not the same. So the graph number 2 is not the same, does not have that same constant of proportionality. So graph number 3 is proportional. It does pass through the origin with a line. So we can pick any of the ordered pairs on that line. Let's choose 3, 1. So now 3, 1, we have an x value of 3 and a y value of 1. So the ratio of y over x is equal to 1/3. So the constant of proportionality is 1/3. It matches, it's the same as the equation. So graph number 3 is going to be a part of our answer. Now all we have left to check are the tables. We have table 4 and 5. In a table, to find the constant of proportionality, we just need to look at the ratio of any of the random y and x columns. So in number 4, let's look at the last one. Let's look at the ratio of 29.1 over 9.7. That's y over x. So again, 29.1 over 9.7, but that's going to give us 3. Even if you did 4.8 over 1.6, negative 4.5 over negative 1.5, that has a constant of proportionality of 3, so it's not the same as 1/3. Finally, in the fifth table, let's do the same thing. Let's randomly pick one of our columns for our x and y values. Let's do maybe the third one here. We have y equals 0.5 and x equals 1.5. So our ratio of y to x would be 0.5 over 1.5, which reduces and simplifies to 1/3. Even if you did 0.8 over 2.4, negative 0.9 over negative 2.7, negative 1.8 over negative 5.4, that always will reduce all of those ratios of y to x to 1/3. So we have a constant of proportionality for the fifth table as 1/3, which is the same as the equation and the same as graph number 3. So graph number 3 and table number 5 have the same constant of proportionality, that 1/3, making our answer choice D.